All right, good morning, guys. So today we're going to look at lesson 10.2. It is a lot of vocabulary again, just like lesson 10.1. So you'll find a blank copy of the notes and my answer key on Google Classroom. I'm going to go through the verbiage, the terminology, the vocabulary, and draw diagrams to try to explain it, because that's basically a lot of the lesson is understanding the terminology. All right, so the first thing we're going to talk about is a central angle of a circle. So if we have a circle, all right, we have the center of the circle. We'll call that A. Okay, if we have an angle whose vertex is on the center, call this B and C. This angle is known as a central angle. So a central angle is an angle whose vertex is on the center of the circle. And we're going to learn that this central angle is equal to the arc that it intersects. So if this angle is 50 degrees, then the arc is 50 degrees as well. Okay, I'm kind of getting ahead and jumping around a little bit, but we're going to learn that the measure of angle BAC is going to equal the measure of arc BC. And we'll use a little arc symbol. So I'm talking about this arc here. Okay? So a central angle is equal to the arc that it intersects. All right? Next is a minor arc. Well, this is an example of a minor arc. Okay? By definition, a minor arc is an arc with a measure less than 180 degrees. So arc BC is a minor arc. All right? Next, we have a major arc. So I'm actually just going to add another point to this circle. I'll call this D. Okay, a major arc is an arc greater than 180 degrees. So for this example, if we're looking at arc BDC, that's this arc right here, okay, the measure of arc, or excuse me, let me first just talk about the arc itself. Okay, arc BDC is a major arc. And to find the measure, well, if this arc is 50 degrees, and we know that there's 360 degrees in the entire circle, to find the measure of that arc, you would take 360 and subtract away the 50. So the measure of arc BDC is equal to 360 minus this 50, that piece there. So that'll give you 310 degrees. Okay. All right, next we're going to talk about a semicircle, but let me erase what I have so I can kind of start from scratch. So a semicircle, it says an arc with endpoints that are the opposite, let me read again. The arc with endpoints that are the endpoints of a diameter. Okay, so a semicircle, I'm sure you guys probably could guess what a semicircle is anyway. If I divide this circle in half with the diameter, just so it matches my notes, what do I use? I use Q, P, and R. Okay. P is the center, QR is the diameter. So a semicircle, half the circle, would be this arc right here. Okay, now I'm going to add another point to the diagram. What did I use? I used an S in my notes just to be consistent. Okay, so if I was to talk about this arc right here, arc QSR, okay, that arc right there, that's a semicircle. And it measures 180 degrees. It's half of the whole circle. Whole circle is 360. Half of the circle is 180. All right. Measure of a minor arc I already talked about. I already talked about measure of a major arc as well. Now let's talk about adjacent arcs. All right, so let's see my diagram that I used in the notes. I have a C, an A, and a B. Okay, so there are a few different arcs we could focus on here. So adjacent arcs, we talked about adjacent angles earlier in the year. Adjacent arcs are arcs that are right next to each other. So for example, I talked about arc AB, this arc right here, and then arc, what did I say, BC. I could have said AC as well, but I just want to match my notes. So arc BC right here, if I can trace a little better. Those two arcs are next to each other. They're adjacent arcs. So arc BC and arc AB are adjacent arcs. They're next to each other. Okay. Next thing we have are congruent arcs. Oh, no, we don't. I missed one. What did I miss? Congruent circles. Back for a second. Okay, so congruent circles are circles that can be mapped onto each other by a rigid motion. We talked about transformations earlier in the year. So rigid motions are transformations that produce congruent figures. So rigid motion or composition of rigid motions. Okay, so if we have two circles and I named them P and Q in the notes. So if I have a circle P with a radius of 4, and if I have a circle Q with a radius of 4, those two circles are congruent circles. So I could say circle P is congruent to circle Q. Okay. Next we have congruent arcs. So let me get my diagram up here. So the image I have in the notes, C, E, F, E, and D. And in the notes, I made both this angle is 80 degrees and this angle is 80 degrees. So the definition of congruent arcs, it says arcs that have the same measure and arcs of the same circle are congruent angles, or congruent, circles. So because both of the central angles are 80 degrees, that means that the arcs are also 80 degrees. Therefore, the arcs are congruent. Because remember, this central angle is going to equal the measure of the arc that it intersects. So this arc is 80. This arc is 80. Okay, so I know the central angles are equal. Now I know that the arcs are also equal. So I can say that CD, arc CD, is equal, the measure of arc CD is equal to the measure of arc EF. Or, to change up the notation, I could say that arc CD is congruent to arc EF. Okay. And finally, similar arcs. All right, so let me draw my diagram. So I have the radius, the radius, the radius of the bake, the radius of the bake, and I use letters Q, S, U, and R, T, and I also have 90-degree angle. All right, so similar arcs that have the same measure. Okay, so these two circles, the small circle and the large circle, they're not congruent to each other. But one thing we're going to talk about in a second is all circles are similar to each other. So the big circle and the small circle are similar to each other. Now, yes, this central angle is 90 degrees, so the arc is also 90 degrees. This central angle of the small circle is 90 degrees, so this arc is 90 degrees. But we know that the arcs are not congruent to each other because the circles are not congruent to each other. But I can say that arc RS is similar to arc TU. Okay, they're not going to be congruent to each other because the circles themselves are not congruent. The circles are similar. Okay. Now, flip to the next page in your notes. I'll do 4 more quick examples. So we have some postulates and theorems to go through. I'll read them to you, but then I'll draw a quick example on the board to illustrate. So the first is the arc addition postulate, which says the measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. Okay, so for example, if I had a circle, its name is E, circle E, then I have D, A, C, and B, and then the arcs are labeled 5x, 40, 70, and 75 plus 2x. Okay. So the question here would be, or what it says in my notes, is to solve for the value of x and then find the measure of arc AB. Okay, so what do you know about all the arcs of a circle? What do they all add up to? They all add up to 360 degrees. So that's the first thing I'm going to say. I'm going to say 5x plus 75 plus 2x plus 70 plus 40 equals 360 degrees. Now I can combine like terms, right? I can combine my x's to get 7x. And I can combine 75, 70, that's 145, plus another 40, that's 185. And set equal to 360. Subtract the 185 from both sides, so you're going to get 7x equals 175. And then divide both sides by 175 to get, by 7 to get x equals 25. All right. Once you know the value of x, the question was really asking you to find the measure of arc AB. So the measure of arc AB is equal to 5x. But now I know x is 25. So 5 times 25 equals 125. All right, so this arc is 125. I could also figure out the measure of arc AD if I wanted to, right? It doesn't ask you to, but you can plug 25 in there as well. Okay, so that is the arc angle arc addition postulate. Just you can add angles or arc measurements together. Next is the congruent circle theorem, which we actually already addressed in the vocabulary, so I'm not really going to go over that. If 2 circles have the same radii, then they are congruent to each other. Okay. The next is the theorem that says congruent central angles theorem. In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding central angles are congruent. So the example I have for that one, if you have a diagram that looks like this, so in this case, I'm just looking at one circle. A, C, D, B, and the middle point is E, 105, 105. So this theorem tells us that if the 2 central angles are equal to each other, well, then their arcs are also equal to each other. So since this angle is 105 and this angle is 105, I know that this arc right here is going to be congruent to this arc right there. Okay, so AC, arc AC, is congruent to arc DB, or BD, if and only if the measure of angle AEC is equal to the measure of angle BED. Okay, so since that's an if and only if statement, a biconditional statement, that means the converse is true as well. So if you were given that this arc is congruent to this arc, or this arc measure is equal to this arc measure, that allows you to conclude that the angles are congruent, or the angle measures are equal as well. Because it's a biconditional, so the converse is true as well. All right. And the last example, I kind of spoke about a little bit when we were going through the vocabulary, about similar circles. Okay, so all circles are similar. Okay, the very basic definition of similarity when you were younger, we would say similar objects, similar figures, same shape, not necessarily the same size, right? So if you have two circles, circle A and circle B, all circles are always similar. They're the same shape, but they're not the same size. But you could say that circle A is similar to circle B, okay, because they are the same shape. All right, that's it for the notes for today, guys. So jump on over to Google Classroom, check out your homework assignment. I'll see you tomorrow. Bye.